Okay, so yesterday we were talking about how to split, and we found that we can do a split on a feature, but we still don't know how to select the feature split. We know how to split based on each of the categorical variable value. We can split the data. For example, if it is credit, each of the value that the credit can take, you split it into different groups or different branches. Each branch will be able to uh, separate the safe and risky loans into different categories or different buckets. We'll be able to count the number of safe loans after splitting and number of risky loans after splitting, and we'll be seeing what are the counts. If only one category emerges and the remaining categories are zero, in this case this is zero and this is non-zero. So if that is the case that we are entering into, then we say that it is a pure node. If the node doesn't have a zero, one of the category counts as zero, then we say that that particular branch is an impure node. Now we are always interested in the pure node because pure nodes predict with confidence that this is a safe loan or this is a risky loan. It will predict with a confidence. But in impure nodes, sometimes it is risky, sometimes it is safe. So we go by the majority class, but majority doesn't mean that we are going to have the same level of confidence that we have on the pure node. So predicting on a pure node is much more safer. So what we did is we predicted on the first node as safe, but the remaining nodes, because they are impure, we try to split the node again. If we split the node again, probably or hopefully we'll be getting a better split where we are going to get a pure node. So that is the idea that we are going in. Is it clear so far?
Yes, Sandeep.
Okay. So what we do is, if there is nothing more to split, we make predictions. If there is something to split again, then what we do is we go back to the step 2. We select another feature to split the data on, and then again split it. So we keep on splitting the data or keep on splitting the tree until we get a pure node. Then we go to the step 3 and stop the process. So now the question is, until when we keep on splitting, which is the stopping criteria, the problem number 2. And problem number 1 is how to select the feature. First of all, I have 100 different features, how to select the feature. So these two are very important, and without which we cannot complete the process. So how to learn this decision stump? Decision stump is nothing but the split. How to understand which one to split, which feature to split on. Now you start with the given data. I assume here we're assuming n equal to 40, and we have 3 features. N equal to 40 means number of rows. So we have 40 rows. And we have 3 features. Feature number 1 is credit. Next one is term. Other one is income. Using all of these three features, we can start learning the decision tree. Now initially assume that all the safe loans, there are 22 safe loans and 18 risky loans at the root node before even splitting. Abid, do you have any question? Okay, it is
No,
Zahir.
I'm not sure.
Okay, it is Zahir. Okay.
Yes,
So,
Amit.
hi Zahir. So assume that at this point you have 22 safe loans and 18 risky loans that you have given, which means the overall number is 40, which is what we have assumed initially. So at the root node, you don't have any split. So at the root node, you know that there are 23, 22. You just counted for the number of safe loans. The data is like this. You kept on counting. This is 1, 2, 3, 4, 5. Likewise, you counted until 18 safe loans. And the remaining ones will become risky loans, so that the overall number becomes 40. That is your assumption. Now, if you want to predict at this point itself, you have to always predict the majority class. In this case, majority class is safe loan. But this is not a right approach, because majority class is not giving a proper way, because every time you are going to predict only safe. This is not going to solve any problem for us. So that's why we start splitting it. So we start splitting on credit. I don't know, it could be income also. But let's try to split by credit. If we predict, if we try to split by credit, then we have excellent, fair, and poor as the answers, or the branches. Each branch, you can try to count the number of excellent, number of safe loans versus risky loans when credit equal to excellent. Number of safe and risky loans when credit equal to fair, and same thing for poor as well. Now you can see here, this one is very good, because this branch is always saying it is a safe loan. When credit equal to excellent, always it is saying that it is a safe loan according to the data. But the other two branches are not so good, because these two are impure nodes. Impure nodes are something that I don't have the proper split. There is no, I cannot tell if it is a safe loan or risky loan. Probably I can go by the majority class. In this case, I can say safe loan. In this case, I can say risky loan. But the only difference, only problem is, the problem here is, when you are predicting a safe loan here versus when you are predicting a safe loan here, there is a lot of difference. Here, sometimes even if I predict safe loan, it might be risky loan, because both the counts are present. None of them are zero. But in this case, I can always predict safe loan and I am always right. So that is the difference between when I predict on an impure node versus pure node. So I don't want that. I don't want to go, I don't want to do a mistake like this. So what I do is, I'll always predict safe loan when there is a, I'll always predict when there is a pure node. I'll not predict anything when there is an impure node. What I'll do is, I'll try to split it again. But the question is the first split, which is the credit, is it right or not? So I started with credit. I did a split on credit and I got this answer. But if I split on income, or if I split on term, I might get a better answer. So the question is, if I split on income or term, will I get a better split? Now, if I get a better split than this one, I should go with that particular variable, not credit. Now, how do I know that if it is a better split or not? Yeah, this is what he is saying. You can predict based on the majority value, but that is not accurate. So how do I select the best variable? If I split on credit, it is giving this answer. Maybe if I start splitting on income, just by discarding this, if I discard this and start using income, maybe I may get a better answer. Or maybe if I don't use this and use a term as a uh, feature variable on which I want to split the decision tree, maybe I get a much more better answer. So these are some decisions I have to take before I can build a decision tree. Now, how do I know that which is the best feature to split on? So first, what we can do is we can start splitting on the credit, but you can also split on term or income. So what you can do is you can try to split on all of them. Try to do it on credit, try to do it on term, or probably on income as well. You try on every feature that is available to you and try to split it and get these intermediary nodes or branches. So once we get these branches, we need to identify which kind of branch is very good. Is these three branches good, or these two branches are good? Now the question is, how do we know? But just before understanding which one is better, just go through these two branches, these three branches, as well as these two, and tell me which criteria is good, which choice is good. Is choice one good or choice two good? Just by inspecting. No need to find out any mathematics or anything. Just go through the uh, nodes that are split on and see which one is looking much better. Is term looking much better or credit looking much better? Just try to look into it. So on credit, you have excellent as 9,0, which means all the 9 are safe loans, 0 are risky loans, which is a good node. It's a pure node. And here it is saying 9,4 and 4,14. So 2 impure nodes and 1 pure node. And on term, you are seeing 16,4 and 4,14. I think these two are almost same. Here it is a 16,4, but there is no pure node on the left side, on the right side. On the left side split, there is a pure node. On the right side split, there is no pure node. So which one according to you is good? Abid, what about you? What do you think? Just by plain intuition, you can tell me. No need of any mathematics. Just look at the numbers, how the split is happening, and tell me if it is good or not. Abid, are you there?
Yeah, I'm here, Sandeep. I'm just thinking.
Mhm. Vidya, what do you think? Which one is better?
Um, like if I intuition wise,
We can say the left one is better. Split
yeah,
on credit.
Mm-hmm.
yeah, because credit history is more relevant to how you're gonna pay back and things like that. Term, yeah, it kind of plays in, but not so much as credit.
No, I'm asking you to look at these numbers, not the variable. Variable can be, I can call it as X and Y. I don't know what it means. Now tell me the answer. I don't know what is this X. I don't know what is this Y. It may be credit, it may be term, whatever it is. After splitting, I get these kind of numbers on each of these. Okay.
I mean, I would pick the Excel and 9 and 0.
Yeah. Why? It's because you get one pure node.
Yes.
Okay. What about you, Abid and Zahir? Zahir might not have got the full intuition. I'm not sure. Abid, what do you think?
I can say split on credit, sir.
You can split on credit. Okay. Why? What is the reason?
And if his credit history is good, he can grant the loans.
No, Lyle, that's what I'm saying. Did you not hear? Do not look at the variable name. Look at only the values after splitting.
I can say as it is a pure node.
Okay. Zair, what about you? You have the same answer and something different.
I'm thinking the right side term because between 3 and 5 years you have better data points on 16.4 and 6.14.
Okay.
That tells me there's a nice split between the term, and the points point towards picking the term as a possible option.
Mm-hmm. Okay. Yeah, that could be also one more way of saying. So it means that there is no one single answer. That's what I'm trying to explain. So there is no single answer saying, okay, you have to always go with the number of pure nodes that you get after splitting. Maybe after splitting here, maybe you get a better answer than this one. So it's very hard to say which one will be good in future. For this split, probably both are looking same for me, because the number of wrong answers are same. So here assume that it is uh, a safe loan finally, and your prediction is also saving safe loan. So the number of wrong answers here are 4. 4 times you are going wrong. Otherwise, all the 9 times, the remaining 9 times you are saying correctly. Assume that this is a risky loan branch. Actually, it is risky, and you are predicting risky as well. But 4 times you are again going wrong because you are saying your data is saying 4 times it is safe. So the number of wrong answers here are 4 plus 4, which is 8. Are you clear what is this wrong answer? Assume that this is really a safe loan. In this branch, if you predict safe, you're 9 times correct. 4 times you're wrong, because 4 times the data is saying it is a risky loan. And in this branch, actually assume that here it is a actually the data actually it is risky, and 14 times you are predicting it as risky according to the data, and 4 times the data is also saying it is a safe loan. Now 4 times you may go wrong according to your training data set. So here it is again 4 are the number of mistakes you can do. So the number of mistakes you can do here is 8. Now let's consider whatever the number of mistakes here. This is one way. There are multiple ways. Each way may give you different answer. So do not worry about those. Each way is having some logic behind that. I'm explaining something about the majority class. Now what about here? Assume here it is a safe loan because 16 times actually it is safe loan. So actually it is safe, and 16 times you are saying safe. I mean 16 times your data is supporting that it is safe, but 4 times it is a risky loan, which means again here you are making a 4 on training data set, 4 mistakes you are doing for this branch. And again this is assume that it is a risky loan when term is greater than 5 years. Now or equal to 5 years, term is equal to 5 years. Assume that this is a risky loan, which means on training data set there are 6 mistakes. You are not able to catch those mistakes. Now how many mistakes you are doing? Here you are doing overall 10 mistakes. Here you are only doing 8 mistakes. So which one is better? On a simple way, if you want to see the data in a very simplistic manner, you can see the number of mistakes you can do, number of mistakes on training data set you are doing. So in this choice 1 you are only making 8 mistakes, and in choice 2 you are making 10 mistakes. So which one is better? According to this simple math, choice 1 is better. Are you guys clear on this?
Yes, Sandeep.
So according to the data, how many mistakes you are doing, that you count. If you know the number of mistakes you are doing, then if you are doing more mistakes, obviously you're wrong. It is one of the simplest criteria you can use to find out which one is the best split. Now, based on the simplest criteria, I can say credit is much better than term. Okay. Now, are you clear with this criteria? Number of mistakes you do. Very simple. On the training data set, go and validate how many times you made the mistake. If you're doing more number of mistakes, then obviously you're wrong. And on this pure node, you don't do any mistakes because you always predict safe, and all the 9 are saying it is safe only. So here it is 0 and 4 and 4. These are the number of mistakes you do on each branch. Overall, you're doing 8 mistakes for this split. And here you're doing 10 mistakes because here you're doing 4 mistakes and 6 mistakes. 4 plus 6. Any questions here? Okay. Yeah, any questions?
I'm clear, Sandeep.
Okay. Now, how do we measure the number of, effectiveness of the split? Yeah, like I said, you can use the number of mistakes. So if you're doing more number of mistakes, you're wrong. If you're doing not many mistakes, you're right. So you take that split. But in general, instead of doing the number of mistakes, it's better always to divide by the number of data points it split. So here I took 40 data points. So I'm normalizing the number of mistakes by using, I'm normalizing the number of mistakes by number of data points I actually split. That way I get the fraction of mistakes that I did. So that way I'll be able to understand how much good that split is. For example, if I am doing 8 mistakes out of 40 data points versus if I am only doing 8 mistakes for 400 data points, these two are not same. So taking the number of mistakes itself is not really good. So the idea is, why don't we take the number of mistakes normalized by the number of data points that we already, or the number of training data points that we have. If we have that, then we'll be having an estimate of what is the percentage of mistakes I'm doing or fraction of mistakes I'm doing. So 8 mistakes out of 400 is much lesser than 8 mistakes out of 40. So the reason for normalizing with the data points is to identify how many mistakes I'm doing for the number of data points I do have. So that's why not just using number of mistakes may not make always the proper sense. So we normalize it with the number, we divide it by the number of data points. If we do that, we get a better estimate of the mistakes. Now this error, the percentage of error or fraction of error that we calculate, what is the maximum value that this error can have? Let's say there are 40 data points. Out of 40, all the 40 are mistakes. So 1 is the highest number that I can get for this error. And what is the lowest number that I can get? I don't do any mistakes out of, let's say, 40 data points. So minimum is 0, maximum is 1. So if you are getting an error equal to 1, then you are not doing any proper split at all. The split is completely wrong. And if your error equal to 0, you are getting a pure nodes. All you are getting is pure nodes. Is it clear so far?
Yes, Sandeep.
Yes, Sandeep.
Okay. Now that's what here the calculation is. What about the root node? How many mistakes we are doing? So if we are getting 22 and 18 as the answers, 22 safe loans and 18 risky loans. So we are going to predict the majority class, which is safe. So if we are predicting the majority class, how many mistakes we are doing? So 18 mistakes we are going to do, 18 times we are going to do mistake because we are predicting the majority class. So our error will be 18 by 22 plus 18, which is 40. So this is our classification error before even we started a decision tree model, which is coming around 0.45. So this is our initial error. So whenever we split on any column or any whenever we split the data on any category or any feature, what we do is we'll try to reduce the classification error from the root classification error. If we are going to increase, maybe that is not a proper split. We should take something else. So this is our baseline. We baseline our model saying our maximum classification error that we can get is this one, 0.45, without even splitting. Now what we do, we start using some feature, credit, for example. If we start splitting on credit, are we going to reduce our classification error from 0.45 to something lesser than that? Are we going to get below 0.45 or not? Let's try to do that. Now, these are the previous splits itself, whatever we saw, 9, 0, 9, 4, 4, 14, all these things we saw earlier. Now, what is the classification error here? after splitting. Now the number of mistakes so here we are going to predict as safe loan, and there are 0 risky loans, so there are 0 errors here. Here we are going to say safe loan, which is the majority class, and we are going to do 4 mistakes. And here we are going to say risky, and we are going to do 4 mistakes, because 14 are the risky ones, which is proper. 4 is the safe loans, which is wrong. Actually it is risky we are predicting, and 4 times we are going to go wrong. So the number of mistakes are 8 out of overall 9 plus 9, 18, 18 plus 4, 22, 22 plus 4, 26, 26 plus 14, it is 40. Out of 40, we are making 8 mistakes. What is the classification error? This is 8 5s, so it is 0.2. 0.2 is our classification error after splitting on credit. Now what happens if I split on, this is the same thing, split on credit, you get 0.2 as the final error after splitting. So earlier it was 0.45 on the root node. On the root node it is 0.45. Now we split on credit, we get 0.2 as the classification error. So the error got decreased. Now if we split on credit, term, what is the classification error? Here the majority class is safe, so we predict safe. And here the majority class is risky, we are going to predict risky. Now if we stop here, how many classification errors we are going to get? I mean, what is the percentage of classification error we are going to get? So here we are going to say safe. 16 times we are right on the training data set, but 4 times we are wrong. We are completely wrong actually. So 4 is the number of times we are wrong here on this branch. On this branch, we are going to predict it as risky, but on the training data set, there are 6 safe loans, which means 6 times we are going to go wrong. So 4 plus 6 is the number of errors we have by the total number of elements we split it on. 16 plus 4, 20, 20 plus 6, 26, plus 14, 40. This is the total number of data points that we split on. Now what is the data? What is the classification error? 10 by 40, which is nothing but 0.25. So if we split on term from the root node, on the root node we have initially 0.45 as a classification error. If we split on credit, it is 0.2. If we split on term, the classification error is 0.25. Now which one to split? Now it is very easy. Whichever split is having the least classification error, take that one. Here I am having the least classification error on credit, so I go and split on credit. So I have the best feature now. Now from the root node, which one to split? Start with the credit, which is having the best classification error. So we have 2 choices. Actually we have 3, but in this PPT they gave only 2 choices. Actually the third choice is split on the income. So you have to split on credit, term, income, find out the best, find out the split on which you are getting the best classification error, declare it as winner, and split and continue splitting on that branch or on that feature. Okay. Now you have a winner, which is credit. Now, after you selected the credit to split on, again, what you have to do is you have to find out the remaining, find out the branches where there is no pure nodes. This is a pure node, so I won't touch this one. This is an impure node, and this is an impure node. So on these two branches, on these two nodes, again you try to find out the best feature to split on. Credit is used. Do not again use credit again. So when you try to split again, do not use credit. Use something else, maybe term or let's say income. Two features are available for you to split. Credit is used already. You have used credit to split in. So what is the algorithm for feature split? Given a subset of data, which is our training data set, for each feature, split data of M according to the feature. So you're going to split the data. That's what we have done. Compute the classification error on each split. You do it for each feature. Every time you get some classification error, find out the feature which is having the lowest classification error and use that for the decision tree. Are you clear with this so far?
Yes, Sandeep.
Others? I don't see anyone responding.
No, yes, Sandeep.
Okay. So that's how you do the feature selection. Once you pick the best feature for each split. So if you see this is the initial algorithm we started with. Start with an empty tree for each split. I mean, take a feature to split. For each split, if nothing more to split, then stop the make the predictions. Otherwise, recurse, which means you go on splitting the data, splitting the tree. This is the original one. Now, the step 2 is much more refined. Now we know that how to select the best feature. Select a feature to split the data, which is nothing but this entire algorithm. We know how to split. I mean, we know how to select the feature actually, not how to split. Now, when to stop? If you go back to our initial set of problems that we did not understand fully, it's long back, yeah. Select a feature to split. This is what we understood, how to select a feature to split, we understood. Now the second problem here is, the first problem is we don't know how to select a feature, that we understood just now. The second problem is how to stop or when to stop. Here it is saying if there is nothing more to, then make predictions. So what is there nothing more to do? So what is the stopping condition? When do you stop actually? The other one is recursion. Recursion is something that we'll easily understand. We'll do that later. But stopping condition is something that we don't know. Now we'll understand that one. Now what are these stopping conditions? So we have learned a decision stump. Decision stump is nothing but this one. Some criteria on which you have to split. That is called decision stump. Now we have already learned the decision stump. Now what should we do next? We cannot split anymore on this one because it is a pure node. Always it is predicting safe. What more to split? And even if we split, what is the advantage you are getting after getting a pure node? So we don't continue from the pure node. We'll stop it because it is very easy for us to understand that all are safe loans. There is no risky loan. So there is nothing to do with this kind of a node when there is a pure node is present. So there is nothing to do there. But what about fair and pure? We are doing some mistakes. We have to correct them. To correct them in decision trees, all we have to do is we have to build another decision stump below that fair and poor. So below this fair, try to understand which is the best feature to split. Let's say income is the best feature in this case, let's say. Then create a decision stump on income when it is high, low, or moderate, whatever it is. Try to learn one decision stump again and split these 13 data points. Overall, there are 13 data points, 9 as safe loans, 4 as risky loans. All these 13 data points, try to split again. If you split again, hopefully we are going to get another pure node, another set of pure nodes. That is the reason why we are splitting again. Similarly, for poor also, maybe for poor, maybe term is a better indicator of whether it is a safe loan or risky loan. So try to find out the best possible split among term and income. Do not take credit again, because credit is something that you already splitted the data on. You will not gain anything if you take credit again. So discard the credit, but start using term and income and try to find the winner the way we found earlier. Find out the classification error when you split on term, when you split on income. Find out which one is better among term and income according to the classification error, and select that as a winner. And this is nothing but recursion. Why is it is recursion? We are doing the same decision stump learning again after splitting. So we splitted at this point, we got these nodes. Again, we are trying to do the same kind of split on a different variable. So that's why it is called recursion. You are doing the same thing again and again until you are done. Okay, are you clear? Before I clean up this is a useless one. Okay, let me remove it then. Now again, you try to do the same thing. Like I said, when it is fair, maybe term is the better decision stump. Here he did not give the reasons again, but you can see that out of term and income, it looks like term is much better. So we split on term, and you can see this is a pure node and this is also a pure node. So we stop it here. And on the poor, out of 14 safe loans and 4 safe loans and 14 risky loans, we split on income again. We got income high as 4,5, 4 safe loans and 5 unsafe loans or risky loans. Here we got another decision, another pure node. So here I don't have to build anything, but I have to build a decision stump on income equal to high. This is something I have to again split on. So this is second level split. That's why it is saying second level. Now, what do I do again? I build another decision stump, but this time, what are the remaining variables I have? We used up credit, we used up income, we have only term. There is no other alternative. So there is only one node that I can split on. So I use the same node to split, which is term. There is no selecting, we don't have to select the features because we are only having one feature. So if we have feature A, feature B, feature C, then you can go select one best feature. But if we have only one feature, which is A, there is no best feature that I want to select. Go for it. So I have only term as the feature that is present. I use that feature and split it again. Now I get 2 branches. One is a pure node, but still another is an impure node. Now the thing is, can I split on any other variable? I used up credit, I used up income, I used up term. I have 3 variables. All the 3 variables I have used up. So I cannot split on any variable after this. So what I did is I predicted it as safe. Whatever is the majority class, I predicted. There is no way I can split it again. It's okay. So I'm making some 3 mistakes, but I still because I don't have any choice, I stop it here. Are you clear? What happens total end to end?
Yes, Sandeep.
Okay. So this is called greedy algorithm. Why it is greedy? Because at every level, at every branch, at every level, what I am doing, I am taking the best feature. At every level, I am taking the best feature, thinking that if I split at this level as with with a best feature, overall the tree will be best tree. It may happen that even if credit is not a best feature to I mean, even if term is not the best feature at the first level, if I split at the term, maybe I may be able to get a best tree. But what I'm thinking is I'm thinking greedily and thinking that at every level, whatever features are available to me, if that feature is the best feature, I'll select the best one, hoping that overall it is going to be the best one. Okay, this is called greedy algorithm. So we are talking about simple greedy decision tree learning. So in that, what we should do, pick a best feature, learn the decision stump, which is the branches to split on, and for each leaf node, recurse again. Now when do you stop? This is a loop, right? Pick a best feature, learn decision stump, for each leaf, again go back and pick a best feature, do it again and again. This is more like a loop. Now when do we stop? So the first thing, stopping condition 1, if all data agrees on y, what does it mean? It is a pure node. So here all the data agrees on safe. None of them is saying risky loan. So you don't have to worry about splitting it again. Here all the data is saying it is risky. They are agreeing to same point. They are not saying nothing is safe in this data, in this node. So again, this is a pure node. So if you see all of this one, this node, and this node, all of them are pure nodes. There is no impurity in any of these nodes. So when you have a pure node, stop the splitting. What is the second criteria? Already split on all the possible features, nothing to do. So you split on credit, you split on income, you split on term, and now there is an impure node. You used up all the variables that you have at hand. There is no variable that I can start splitting your data on. So this is a second place where I can stop, because I don't have any features left over. So this is stopping condition 2. If you already split on all the features, then stop it. So I think we solved all the problems, how to create this decision tree learning. We found how to split the feature. We know that there are many metrics. What we used is the classification error, which is the number of mistakes or the fraction of mistakes that you are doing. And when to stop? we have stopping conditions 1 and 2. Stopping condition 1 is when you have a pure node. Stopping condition 2 is when you have a decision stump, or when you have an impure node, but you have already used up all your features to split on. So with this, we know the entire learning aspect of decision tree. Now, how to make predictions. Before going with all these things, let's take a break. We'll take 8 minutes. Today we might have lot of time. We'll take 8 minutes. We'll come back at 7:30. Is that fine?
Yes, Sandeep.
We'll come back at 7:30 then. Is everyone back?
Yes, Sandeep.
Okay. Abid, are you
Yes.
back? Yeah. Zahir? Okay, fine. So how do we traverse the decision tree? Traversing doesn't mean anything. It means that you flow through the graph or the tree. So given any data point, when credit equal to poor, income equal to high, term equal to 5 years, given any data point, what you do is you start from the starting node, then you flow through this credit, and you know that credit equal to poor for any for this current data point. So you go to this line, and income is equal to high here, so you go here, and then term equal to 5 years, so you go to here, and then for any given data point you go to the leaf node. Leaf nodes are something that you get at the end, this is what I told you at the beginning of the yesterday's class. So leaf nodes are something that you see at the end. So finally you go to the leaf node, and whatever the leaf node is saying, you predict that one. Here the leaf node is saying safe, so predict safe. So for any given data point, so for any new data point, you flow through this tree and then predict the final result. That's how you can do the predictions. Now you can easily see that the advantage of the decision tree, it's highly interpretable. So in machine learning, there are two kinds of models. So you can divide the machine learning models into two types. There are many different ways you can divide the machine learning models into types, but this is more about the white box and black box models. So you can divide the data, the machine learning techniques into white box techniques and black box techniques. So white box technique is nothing but this kind of a decision tree. So what is the white box technique? You know why a particular data point is predicted safe loan or risky loan exactly. You know very clearly why it is a why it is a safe loan, or why it is a risky loan. So for example, in this case, I am predicting it as safe loan. Now, why is it safe loan? You can easily say when income is equal to poor and credit equal to poor and income equal to high, and term is 5 years. If this is happening according to the decision tree is predicting safe loan. With this data, always you are going to predict as safe loan. Or someone says, gives some other example, let's say credit equal to excellent and term equal to 5 years and income is low. So if this kind of a person comes in to the bank, you will immediately again go through this logic and say when credit equal to excellent, you predict safe loan. So someone can start disputing with you, saying why did you give a loan to this particular person when his income is low? Why did you approve the loan even if income is low? And why did not you approve my loan even if income is high? Even if income is high, there is a chance that I can go into risky. So why did you not approve my loan when my income is high? This kind of a dispute might come. So what do you answer? You can easily answer saying your credit history is poor, as well as your term is low, or term is only 3 years. That is why we rejected your claim or your loan application, but the other person, even his income is low, his credit history is excellent. So that's why we predicted a safe loan. So we can give this kind of a reasoning when you apply a decision tree. But when you apply some other techniques, you'll not be able to give this kind of a proper reasoning. So when you can reason out why something happened or something did not happen in machine learning model, then it is called white box model. Simply, you can find out the reasons for the decision. When it is a black box model, you do not have this luxury. You cannot reason out the decisions. So two kinds of machine learning models are present. One is white box techniques, another is black box techniques. One is white box techniques and another is black box techniques. White box techniques is something that if some decision is taken by the that particular machine learning model, if someone questions you why is this way, you can go back to your decision tree or any other white box technique model and understand what really happened behind the scenes. Black box technique is something, it is very, very hard to reason out. In fact, it is impossible to reason out. In many cases, you cannot reason out why it happened this way. Just because machine learning model said so, you decided that it is a safe loan, but you do not know whatsoever what happened internally. So some of the white box techniques are regression, decision tree, and there is no pure white box models, pure black box models, you cannot say. Many of these techniques, partially they are white box, partially they are black box. For example, regression. Regression is a considerably more black box, not so white box model compared to decision tree. Decision tree is a plain white box model. It is everything is visible, everything you can interpret. It's very, very easy. Regression, it is a white box, but not as clean as decision tree. Because here you have all the formulas, y hat equal to beta naught 1, beta naught plus beta 1 x plus, all those formulas. So it's a kind of a little bit black box than decision tree. But overall, I can classify it as a white box model. It's a transparent model. But if you see black box models, here I can give examples. We did not cover any of these topics. One is support vector machines. It is a very, very difficult to identify whether it, what is the reason that support vector machine gave this answer. It's very, very hard to reason out. In fact, it is impossible to reason out as well. Neural networks. Again, same problem. Very hard to reason out. There is another technique called KNN, which is a kind of white box, but it's not really as white as regression and decision tree. Little bit more difficult to interpret, but we can classify it as we can classify it as white box model. We are going to see KNN model as well, nearest neighbors. Okay, are you clear so far? I'll give you a simple example. I gave you a picture of tiger and a cat. 2 pictures. I gave you 2 pictures. Okay, anyway, I don't want to correct the English. I gave you 2 pictures. One picture is of tiger and another is of a cat. Now, I asked you to identify, and you say you correctly identified which one is tiger, which one is cat. That is okay. But then I'll ask you, what is the reason you identified this as a tiger? Or what is the reason you identified this as a cat? So it's hard to tell for you how you identified a picture of cat versus how you identified a picture of tiger. But you can implicitly define what is tiger, what is cat internally to your brain. But you cannot express it so easily. That is the same thing that I'm explaining here. Black box technique is something that I cannot explain, but it works well. White box techniques, again, it works well. It's not really that it is not working well. But I can explain as well as I can, I can classify properly, as well as I can explain also why I classified like this. There is a proper reasoning. So these white box models are more like that. Black box models I cannot interpret. I cannot tell why. I can only say the answer. Is it clear, everyone?
Yes.
So did you understand what is a white box and black box model and why you cannot? Maybe I can ask you, pictures of tiger maybe. Versus cat. Can you tell why these two are different? I can say this is different from this. Why is it different? Maybe it is looking the same way. I don't know. It's hard to explain. It's something that I know for sure, but I cannot explain. Are you clear?
Yes, Sandeep. So this tiger and cat, I can say, I mean they are black box models.
Mm-hmm.
So coming to the difference.
White box I already showed, right? What is
Yes.
White box? It's a decision tree.
Decision tree.
I can show how exactly I am traversing through the tree. What are the exact rules I'm defining safe loan and risky loan? Everything I have.
Yes, Sandeep. You can inspect each and everything what's going on in the algorithm.
Yeah, if someone comes and asks, why am I not approved for loan? You can clearly explain this is the rules that we are following. It's nothing but a set of rules, right? When credit equal to poor and income is equal to high and term is less than 3 years, I define you as a risky loan. When credit equal to poor and income is low, which means it is always risky. When credit equal to excellent, always it is safe, no more conditions. I have a set of rules on which I can define all these decision trees. I mean, all these decisions I am taking. Okay. So that is the reason I can easily define this. Now, how to predict? So yeah, do not worry about this algorithm. We have no use of it actually. Don't worry about this. Now, what about multi-class? If you have more than one class, how do you predict? Until now, I have only 1 or 2 classes. I just mentioned 0, 4, 9, 0, all these kind of numbers I gave. That's how I decided which one is pure node, which one is impure node. And I could split also easily. Now, what happens if it is a multi-class classification? Multi-class means more than one class. Instead of saying safe, risky, and risky, maybe risky is not a better word or better category. The better way is safe, risky, as well as dangerous, because this way this guy will completely abscond. At least this guy will pay. Safe means he will definitely repay. Risky means there is a chance that he can become a defaulter. Danger means he will definitely become a defaulter. You can define 3 classes instead of 2 classes. Now, for multi-class, how do you define the decision stumps and all those things? Decision stump is almost the same. Is it credit, is excellent, fair, or poor? Is it one of them? But when you are calculating the number of elements, now instead of 2 numbers, you get 3 numbers. One is safe, another is risky, another is, this one is danger. Now out of all these 3, you predict the one which is having the best or majority class. The majority class here is safe, so you predict it as safe. Here again, safe is 6, 9 is the risky loans, 2 is the danger loans. So you predict the majority class, again it is risky. Here it is danger because last one is the majority. So it's almost the same, there is not much difference. And again, if you want to predict the decision tree, the classification error, what you are doing is instead of predicting it as a classification error, you can predict it as a probability. What he is doing is probability that the given y is danger, given that credit equal to poor. Probability that y is equal to danger when credit equal to poor. How do you find the probability? Probability that is danger given we know that credit equal to poor. So given that credit equal to poor means we get only these 3, which is 3 plus 1 plus 7. So out of 11, 3 plus 1 plus 7 is 11. Out of 11, you're getting danger for 7 times, which means 7 out of 11 times you're correct. Instead of talking about error, now I'm talking about the right answers. Out of 11, I'm getting 9 right answers. So that way I can give the probabilities. Similarly, here also I can give the probability of out of 8 plus 9, 17. Out of 17, I am getting 9 right answers. Similarly, here also, out of 12, I am getting 9 right answers. So this kind of probability I can give instead of classification error when you have multi-class. Are you clear with this? I think I can keep this one. Are you clear so far?
Yes, Sandeep.
Is it interesting or boring?
It's interesting.
Okay. Now I know categorical variables, how to split and all those things I know, but because credit equal to his excellent, fair, poor, all those things are categorical variables, and I know for sure how to divide, how to split the tree into each of the categorical values. But what happens if there is a real value or continuous value? So in those cases, how to split the data or split the tree? So for example, instead of income as high, low, medium, all those kind of variables, what if income is a real value? 105K, 112K, 73K, 90K, whatever it is. How do we use these real values? One way to split is for each of these value, I can give a split. For example, 105K, I get one split. 30K, I'm getting another split. 31.4K, one more split. The thing is, how many times in the new data set you get again 31.4K as the income for a new data point, for a new person who is coming to the bank. What is the chance that he'll exactly have 31.4K as his income? It is very rare. Yes or no? Are you clear or not? So we'll have,
I didn't get this part.
so what we did for credit, we did a split on credit equal to excellent, credit equal to good, and credit equal to fair. For each of the categorical value, I did a split. Similarly, if I do a split on income, if it is a continuous variable, on a continuous variable, if I do a split like this, income equal to 105K, income equal to 112K, income equal to 73K. If I do this kind of a split, how many times do you think for a new person who is really applying for a new loan, how many times that new person will have 105K as his income? It is very rare, right?
Yes, something. Yeah, it
If
will be at least one.
so, most of the times what happens is you'll split your data like this. There will be only one data point, either it is safe or risky. Okay, but this is a problem because for a new data point, what is the chance that he'll exactly get this kind of an income or this kind of an income? Okay, he may not get. He may get some other number which is not present in this tree. Here we have 31.4, 39.5. Let's say for a new loan application, I found that 32.6 is the income for that person, and it is not there in the tree, which is a problem, right? If something is not present in the tree, how do I proceed? Until now, for categorical variable, I did not have that problem because whatever is the possible values I kept in the tree. So I'll not get other than good, fair, and excellent for credit, or I'll not get anything other than 3 years and 5 years for term. So that's why I'm safe until now. Now the problem is, it is a real value or a continuous value. I cannot put all the continuous values in this tree. Having all the values in the tree is impossible. For example, very simple. How many numbers are there? How many real numbers are there between 31 and 32? 31K and 32K. How many real numbers are present? Real numbers. Do you know real numbers? How many real numbers are present between 31K and 32K? Infinite. How many real numbers are present between 1 and 2? Infinite.
Infinite.
How many numbers are present between 1.1 and 1.2? Again infinite.
Infinite something.
So if it is a number, if it is a continuous variables are nothing but real numbers. How many numbers I have to keep here? Infinite. I cannot keep like that. Only if I keep infinite all the possible values for income, only then my tree is proper. Otherwise, what happens if I am looking for income? I cannot find the income that I am having, that new person is having, the new applicant of the loan is having. That income, if it is not present in this tree, then we don't have any way of any way to predict. We cannot predict. Now how to predict? So the better way is, instead of splitting on each numeric value, why can't I predict using a threshold? What is this threshold split? Income greater than 60K, income less than 60K. Can I do like this? Now, regardless of the data point, regardless of the the new income that I am getting, I will define whether it is greater than 60 or less than 60. I am always getting into one branch. Are you clear, Vidya, now? Why is it not possible?
Yes, Sandeep.
So that's why you go with the threshold split. Find out a threshold which gives you a better split. Now, what is this threshold? How do I find it? How do I find that it is 60K is better than 50K? You can also argue with me saying this side it is less than 50K. This side it is greater than 50K. You can also argue with me, right? This is also possible. Or maybe Abid might say, no, 40K is much better. Or Zahir might say something else. 100K is good, Zahir might say. Now, which one is better? Everyone is correct. How do I know that which one is best? I can do on any threshold. I can also say greater than 0, less than 0. Only that less than 0 will not come. I mean, none of the data points will come in this branch if it is less than 0. Yes, income will never be less than 0, right? So that is also possible. I can give any threshold. Now, what is the best threshold? How do I find the best threshold? So what I can do is, if you assume that income is all on a number line means, so it starts from 0, 10K, 20K, 30K. All this is, all the incomes that you have in the training data set, keep it on the number line. What you can do is, one second, don't worry about all these things. What you can do is, you can find out the midpoints between every two data points. For example, this is 10K and this is 20K. The midpoint of 10K and 20K is 15K. Find out the midpoint and then try to apply a threshold saying income less than 15K. So this is your root node and this is your income split. Less than 15K is this side and greater than 15K, sorry, it's not 20K, sorry. 15K is this side, greater than 15K is this side. You just count on the training data set, less than for less than 15K, how many safe loans are there? For greater than 15K, how many safe and risky loans are there? You get a classification error. Again, you do it for another midpoint. This is 20K and this is 30K. This midpoint is going to be, let's say, 25K. Again, instead of 15K, take a threshold split of 25K. Again, try to find out how much is your misclassification error or classification error, whatever it is. So how much classification error you have? Again, find out. For each of these midpoints you try out, you get, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 midpoints are there. You get 14 different classification errors, but there is one midpoint which is doing best. That midpoint is what you have to find out. Are you clear how to find the threshold split for real numbers or continuous data?
Yes, Sandeep.
Vijay, are you clear? And Zahir?
Yes, Sandeep.
Okay. Okay. So that's all I have for today. We're already done with the time. We'll catch up tomorrow and complete the decision tree, and we'll go into some other topic called pruning. Decision tree, it's not really complete. It's one of the biggest topics in machine learning. So it will take little more time for us to complete the decision tree. Okay, we're going to go into tree pruning, random forests. Random forest is nothing but instead of having one tree, what is the advantage of having a list of trees or a set of trees? So that also we'll explore. It is called random forest. So we'll go into some more topics like that. Okay. So for today, we'll close the topic and we'll catch up tomorrow again. Any questions so far anywhere?
I am good, Sandeep. Thank you.
Sure. Yeah. Vijay, do you have any questions? And Zahir?
No, Sandeep.
Okay then. We'll catch up tomorrow then. Bye.